This video is about summation, notation, and series. Alright, so a summation is the sum of the first n terms, and it's defined by this equation. This is what it'll look like. Okay, this is called a sigma. It's a Greek letter sigma. The number at the bottom is the number you'll start plugging into the equation over here, and the number top is where you'll stop. Okay, it's a series of numbers. So I'll plug in 1 into this equation wherever there's an I, and then I'll stop when I get there. Hope that makes a little sense. Let me just show you in an example here. With example 1, okay, I'm going to start with a 1, end with a 5, but I'm going to be adding up my results. Okay, so let's just think about this. Plugging in 1 first, 3 times 1 is 3. Done. Move to 2. 3 times 2 is 6. 3 times 3 is 9. 4 is 12. 5 is 15. Okay, so now I take the sum of my results here. So that's 9 is 9, 18 plus 12 is 30, 15 is 45. So I get 45 for my answer. All right, simple enough. Example 2 here. Same process. Look at this one. I start with the number 3, end at a 6. Okay, plugging it into where there's a k. So 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 5 squared is 25 plus 1 is 26. And then 6 squared is 36 plus 1 is 37. So I will use my calculator to find that for me. I get 90. All right. This one, remember, it's a factorial. I'm going to start with a 0 and go all the way to 8. Okay. Now, I'm going to show you on your calculator how to use the sigma notation and also how to use the factorial. Okay, so write the problem down as you see it, and I'm going to switch screens to a calculator. Okay, to do summation, you're going to hit the math button, and then you're going to hit 0. And you should notice that it pulls up a summation for you. So all I did was hit math and 0. And notice it's going to ask you something equals something. Well, this is just any variable. Just keep it x to keep it simple. And then whatever equation you put over here has to have an x. I mean, maybe it's given to you as a t or an I. Just change it to an x, make it simple. So in the bottom of our sigma, in this problem, we put out a 0. So x equals 0. On the top of the sigma, it was an 8. Okay? Over here in the equation, it was a fraction. So I'm going to do alpha y equals, do my fraction. And it was 1 over I to the I factorial. Remember, we changed our variable to an x, so it's x. And then to get factorial, you're going to hit math, go over to probability, and you should see the factorial exclamation mark number 4. And it pops it in there for you. All right, then you hit enter, and there's your solution. Okay, we are going to round to the nearest tenth as always. So our answer is 2.7, right? Nth partial sum of a series, okay? So there's infinite series and there's partial sums, okay? Series. A series is the sum of the first n terms of an infinite series, or it's called the nth partial sum, all right? So if it goes on forever, it's impossible, I mean, it's nearly impossible to add up. But you can do a partial sum, and it shows you how to do that. Okay, a partial sum is like what we talked about. It has a definite beginning, definite ending, and then you plug it into the equation. All right, infinite sum is sum of an infinite sequence. It starts somewhere and it never ends. Okay, so how do you handle that? I'm going to show you how to do that because you can't really put infinite in your calculator. So I'm just going to show you basic process here. On example 4 here, let's type this in the calculator. And you'll get the partial sum because it has a definite ending, beginning and ending. Now, okay, for this partial sum, we're going to walk through the same steps. Go math, 0, get your sigma, and we're going to put in a 1, x equals 1 on the bottom. And on top, it had a 3. And then our equation, we're going to have a fraction, so get alpha y equals 3 over 10 raised to the I power, but our variable is x. Guess what you get? 333 over 1,000. Okay, so there's your answer. For an infinite sum, all right, you're going to just start with the beginning, okay? Plug in a 1. 10 to the first power is 10. 3 over 10. 10 squared is 100. 10 cubed is 1,000. Do you see where this is going? So if I put this as a decimal, that's 0.3. This is 0.03. This is 0.003. What happens if I start adding this up? I get 0.333, and it's going to keep adding 3's as I go on. So really, the infinite sum here, the further I go out to infinity, the more it's just going to be 1/3. So that decimal is really just 1/3. So as you do infinite sums, if you do, you should see a pattern as you convert these to decimals, what's happening here, and that'll give you an idea of where this is going to go if you really did go to infinity. Okay, for class, I want you to try this one. Simple enough, you can do it by hand without a calculator, or you can use the calculator if you have one. Good luck, and we'll see you in class.